Hello students. In this video, I'm going to discuss the problem based on the non-homogeneous linear differential equation. Like in the last video, we have discussed that linear differential equation. This topic is divided into two parts. One is a homogeneous linear differential equation and other one is a non-homogeneous linear differential equation. So in this particular video, we are going to cover the two topics. We are going to discuss the problem based on two topics, method of variation of parameter and method of undetermined coefficient. So before we'll start with the problem based on this method, we will discuss that what about the method of variation of parameter. So firstly, in case of non-homogeneous linear differential equation, non-homogeneous linear differential equation, it is of the type A naught, say nth order derivative y plus a1 and minus 1th order derivative of y plus so on a n y is equal to rx. So basically in case of non-homogeneous differential equation, we have a term, we have a function other than the dependent variable and its derivative, and we name it as a function of x, and we keep that particular term in the right hand side. Okay, so it is a kind of non-homogeneous linear differential equation. So in this case, if y is a solution of this equation, then the y, it can be written as the sum of the complementary function and the particular integral. So what is CF? CF is a complementary function. And what is PI? PI is a particular integral. PI is a particular integral. Complementary function is basically the solution of a homogeneous part of a differential equation. So if I'm assuming it as that y is equal to yc plus yp, so what does it mean that? So if we replace y equal to yc, then in this equation we will get a naught yc nth order derivative plus a1 and minus 1th order derivative plus so on a n yc is equal to 0. So yc is basically the solution of the homogeneous part of a differential equation, and yp is a solution of the non-homogeneous part of a differential equation. Yp nth order derivative a1 yp and minus 1th order derivative plus so on a n yp equal to rx. Okay. So when we are interested to find out the complete solution of a non-homogeneous differential equation, it means that we need to find out two solutions. One is a complementary function and other one is the particular integral. And hence the complete solution is the sum of complementary function and particular integral. So we already know how to find out the solution of the homogeneous differential equation, which we have discussed in our last video. Now, in this case, how do we find out the particular integrals? Our main concern in this video is to find out the particular integral of a non-homogeneous differential equation. So the very first method for calculating the particular integral is the method of variation of parameter. Okay, so what we are going to do in this particular method, let us discuss this briefly. So if we are assuming that your differential equation, say we are assuming a second order differential equation a naught y double dash plus a1 y dash plus a2 y equal to rx, a second order differential equation. So to find out the solution of this equation, firstly we consider the homogeneous differential equation. Consider the homogeneous differential equation. Homogeneous differential equation, that is a naught yc double dash plus a1 yc dash plus a2 yc equal to 0. Basically, we are considering this for the complementary function. Okay, so we write the equation in the operator form as a naught d square plus a1 d plus a2 times yc is equal to 0. And let us say the solution of this equation is given as c1y1 plus c2y2, because it is a second order differential equation, so it has two linear independent solutions, say y1 and y2. Now for particular integral, so we are assuming that a naught yp double dash plus a1 yp dash plus a2 yp equal to rx. Okay, that is yp is the solution which satisfies this equation. So in this case, we start with the trial solution that let yp is equal to u1 y1 plus u2 y2. So here we are simply assuming these constant as a variable, as a parameter. That's why this method is said to be method of variation of parameter. And to find out the value of this u1 and u2, we can use the formula. u1 can be calculated by using the formula. It is minus y2 rx on a naught into Wronskian of y1 and y2 dx, and the value of u2 can be calculated using the formula. It is y1 rx a naught into Wronskian of y1 and y2 times dx. y1 u1 is the coefficient of y1, so while calculating u1 we multiply non-homogeneous part with y2. And what is a naught? A naught is the leading coefficient, and W, that is Wronskian of y1 and y2, because y1 and y2 they are the solution of homogeneous part of a differential equation. So these are known to us. So we simply calculate the Wronskian and we put this value in this particular formula. We can get the value of u1 and u2. And by substituting this value in this formula, we can get the value of particular integral. So what is the complete solution? So the complete solution in this case will be y is equal to yc plus yp, right? One more thing. So like what is yc? Yc is basically c1 y1 plus c2 y2. What is yp? It is u1 y1 plus u2 y2, right? So if we combine them, so we can write it as u1 plus c1 time y1 plus u2 plus c2 time y2. Okay, so if we name it as, say, it is a function of x, say ax y1, and we name it as, say, bx y2, then we can say that y equal to ax y1 plus bx y2 is the general solution of the differential equation. Okay, because C1 and C2, C1 y1, C2 y2 is the solution of complementary part, and U1 y1 and U2 y2 is the solution of the particular integral. Okay, so sometime the question is that we, for what value of Ax and Bx, we need to find out the value of Ax and Bx such that y is the general solution of the differential equation. So while calculating the general solution, we need to add arbitrary constant in the formula of U1 and U2. Okay, and if we are given that y is a particular integral and it is ax y1 plus bx y2, so in that case your ax and bx, they are nothing but u1 and u2 only. Okay, so we can directly solve this particular integral, and in this case we are not going to add any arbitrary constant. Okay, so let us try a problem to understand the concept of this method. So suppose we are given this problem here. The question is, if y equal to ax y1 plus bx y2 be the general solution, which is not the integral, it is the general solution of the non-homogeneous differential equation, where y1 and y2 they are already given to us. Then by method of variation of parameter, what is the value of ax? Like I told you, if it is given that ax and bx, the other coefficient of y1 and y2, and it represents a general solution. So what is ax? Ax is equal to u1 plus c1, and what is bx? Bx will be u2 plus c2. Okay, so what is y1 and y2? They are already known to us. So what is the formula of u1 in this case? So even you can see here in the all the options, constant c is also given here. Okay, so it means that we are going to write ax as u1 plus some constant of integration. Okay, so what is u1? U1 is basically the coefficient of y1. So its value is minus integral of y to rx a naught upon ln square of y1 and y2 dx. So firstly, to find out the value of ax, we need to firstly get the value of rx, a naught and ln square. So I am going to compare the given differential equation with compare the differential equation y double dash plus 4y equal to secant 2x with a naught y double dash plus a1 y dash plus a2 y equal to rx. So here, what is a naught? A naught is given as 1. What is rx? Rx is equal to secant 2x, and y1 is given as cos 2x, and y2 is given as sin 2x. What is y1 and y2? Y1 and y2, they are basically the solution of homogeneous differential equation, right? For example, if we consider homogeneous differential equation, y double dash plus 4y equal to 0. If you can see here, its operator form is d square plus 4 times y c equal to 0. And we are assuming let yc equal to e raised to the power mx be its solution. So you will get its auxiliary equation as by replacing d equal to m. That is m square plus 4 equal to 0. So the value of m square is minus 4. So the value of m comes out to be plus minus 2 iota. So real part is 0, imaginary part is 2. So its solution will be c1 cos 2x plus c2 sin 2x. So what is y1? It is cos 2x. And what is y2? It is sin 2x. So basically they are the linear independent solution of homogeneous differential equation, right? So a naught, rx, y1, y2, they are known. The first step is we need to find out Wronskian. So what is the Wronskian of y1 and y2? Wronskian of y1 and y2 means y1, y2, y1 dash, y2 dash. So if we solve this determinant, y1 is cos 2x, y2 is sin 2x, derivative of cos 2x is minus 2 sin 2x, and derivative of sin 2x is 2 cos 2x. And if we solve this determinant, it is 2 times cos square 2x plus 2 times sin square 2x. So 2 is common, cos square 2x plus sin square 2x. And we know that cos square theta plus sin square theta is value is 1, so its value comes out to be 2. So all the values are known to us. So if we substitute this value in this formula of u1, so what is the value of u1 comes out to be? This is minus of y2. Y2 is sin 2x into rx. What is rx? Rx is secant 2x. What is a naught? A naught is 1. And what is Wronskian? Wronskian is 2. So basically this is minus 1 by 2 is common. Is sin 2x upon cos 2x dx. And here again we are going to use the property that the integral of f dash x upon f of x dx, this is equal to log of f of x plus c, because the derivative of cos 2x is minus 2 sin 2x. So what we are going to do, we are going to multiply minus 2 and divide it with minus 2. So negative sign get cancelled out, so its value is 1 by 4 times log of cos 2x. Okay, but because it is a part of particular integral, so we are not going to add any constant. So what is the value of u1? It is 1 by 4 times log of cos 2x. And because we are interested to find out AX, and it is a general solution. So in general solution, what is AX? It is U1 plus C1. So the value of AX is equal to U1 plus C1. That is 1 by 4 log of cos 2x plus some constant of integration. So you can see here what is the correct answer. Correct answer is option D only, right? Okay. So if we are interested to find out the general solution, so in that case we need to add arbitrary constant. But if here it is given that yp is a particular integral, then we are simply calculating this particular integral and we are not adding any arbitrary constant in this case. Okay. So if we are interested to find out the value of Ax only, then we can get this answer. And if we are interested to calculate the value of Bx also, in this case, we need to use the formula U2 also. Okay, so what is the formula of U2? For example, if I here calculate what is the U2 in this case, U2 is equal to Y1. What is Y1? Y1 is cos 2x. So let us calculate here. It is cos 2x, Rx is secant 2x, A naught is 1, and Wronskian is 2. So because cos and secant, they are reciprocal of each other. So what do we get here? It is 1 by 2 dx. So in this case, answer comes out to be x by 2. So what is the value of bx in that case? So in that case, the value of bx is equal to u2 plus c2. That is, it is x by 2 plus c2. So this is the answer in this case. Okay. So if the problem is based on the method of variation of parameters, so our main concern is we should remember the formula of this u1 and u2 if we are given a second order differential equation. Okay. Let us try another one. So in this case, again, we have considered the same problem, but this time we are given that if yp is a particular integral. A particular integral means that here ax is your u1 and bx is your u2. Okay, well, that is the formula. Here we have used your particular integral as u1 y1 u2 y2. So here this u1 is nothing but your ax and u2 is your bx only. Okay, and again we are interested to find out the value of ax. What is the formula of ax in this case? It is simply equal to u1. So the formula of u1 is minus of y2 rx a naught into Wronskian of y1 and y2 dx. That means in this case, we are not going to add any arbitrary constant. Okay. So if we compare the given differential equation with a naught y double dash plus a1 y dash plus a2 y equal to rx. So what is our given differential equation here? Our given differential equation is x square y double dash x y dash minus 4y equal to x square of log of mod x. Okay, so what is a naught? If we compare them, so we can get here a naught as x square, rx as x square times log of x. Okay, y1 and y2 they are already known to us. So we simply substitute this value in this formula. So we will get here minus what is y2? 1 by x square. What is rx? Rx is x square times log of mod x. What is a naught? A naught is x square. One term is missing here, Wronskian. So firstly, we need to calculate Wronskian of y1 and y2. What is Wronskian of y1 and y2? This is y1, y2, y1 dash and y2 dash. So what is y1? It is x square, y2, 1 upon x square, y1 dash is 2x, y2 dash it is minus 2 upon x cube. So if we solve this, we'll get minus 2 upon x minus 2 upon x, that is minus 4 upon x. So its value comes out to be minus 4 upon x dx. So you can see here this x square and x square get cancelled out. Here also one power of x get cancelled out with this. Negative sign taken outside. This also get cancelled out. So we'll get here this is equal to integral 1 by 4 constant outside. It is 1 upon x times log of x dx. Now here again we are going to use the property of integration. The property is the integral of f of x power n into f dash x. If we have a function with some power into derivative, because derivative of log x is 1 upon x. In that case, we simply use the power rule, f of x raised to the power n plus 1 upon n plus 1 plus c. Like I can consider x raised to the power n dx. What is the derivative of x? It is dx. So what is the answer? It is a power rule, x raised to power n plus 1 upon n plus 1 plus c. So basically, we are using only this identity. So if we use this identity, so what do we get? 1 by 4 already there. So function is log x, its derivative is 1 upon x. So we are going to use the power rule. This is log x squared by 2. So answer is log of mod x squared by 8. No arbitrary constant is added because it is a part of particular integral. So the correct answer is option B. Okay. If the question is to calculate the value of ax only, then we can use this formula. If we are interested to find out bx also, although it is not asked in this question, the question is to calculate ax only. If we want to calculate bx also, what is bx? Bx is a coefficient of y2. So it is y1 rx a naught into constant of y1 and y2. So in that case, what is y1? It is x square. What is y2? It is, sorry, rx. It is x square times log x. And what about a naught? Again, it is x square. And transcend, this is minus 4 by x dA. So here, what do you see here? That one power of x get cancelled out with this. One power of x get cancelled out with this. So we'll get minus 1 by 4 integral x cube time log of mod x dx. So here we can use the product rule to find out the value of this integral. So what is the value of dx? So let us calculate here. Dx is equal to, this is minus 1 by 4 integral of x cube times log of mod x dx. So we apply here the product rule, that is I late rule. So firstly, because inverse function is not there, firstly we need to use logarithmic function, then algebraic function. So this is your first function, this is your second function. So minus 1 by 4 is there, log of mod x first function, integral of second, derivative of logarithmic function, integral of second function, their product, and then again integrate this. So it will give us minus 1 by 4. Integral of x cube is x power 4 by 4 times log mod x. Derivative of log x is 1 by x, and its integral is x power 4 by 4. So 1 power of x get cancelled out. So again, if we integrate this function, so its value comes out to be minus 1 by 4 x power 4 by 4 log of mod x. This is x power 4 by 16. Or I can take x power 4 by 4 outside. So 4 into 4 is 16. So it is log of mod x minus 1 by 4. Okay, or I can take this 4 also common. Then this is minus x power 4 by 64 times 4 times log of mod x minus 1. So this is the value of dx, and what is the particular integral? This is ax y1 plus bx y2. So substituting the value of ax and bx in this formula, you can get the value of particular integral. Okay, so this is how we can apply the method of variation of parameter to find out the value of this unknown parameter ax and bx only. Okay, so here the important thing is, if it is given as a particular integral, then we are not going to add the arbitrary constant while calculating ax and bx. And if it is given that it is a general solution, then we need to add arbitrary constant while calculating the value of ax and bx. Okay. Okay, let us consider one more problem based on this topic. The question is solving by method of variation of parameters. What is the value of Wronskian? So we know that in the method of variation of parameter, what is Wronskian? Wronskian is basically a function of y1 and y2. Although in the last lecture class we have discussed that we can get a formula using Abel's formula, we can calculate the value of Wronskian. It is c times e raised to the power minus a1 upon a naught dx. So what is a naught? A naught is the leading coefficient. A1 is the coefficient of y dash. Okay, so if we use here, then we get c times e power minus, what is a1? Minus 4 upon 1. So it is c times e power 4x. But here you can see here there are two options. Obviously these two are not the correct option, but there are two options where we have e power 4x. So I need to find out the value of c also. So this is possible only if we have a complete information about the linear independent solution of homogeneous differential equation. So it means that we need to find out the complementary function in this case. So for complementary function, we need to consider the homogeneous differential equation. Consider the homogeneous differential equation. It is yc double dash 4yc dash plus 3yc equal to 0. Equation in the operator form is d square minus 4d plus 3 into yc is equal to 0. Here, of course, d stands for d by dx. So we are assuming let yc equal to e raised to the power mx be its solution. So its auxiliary equation will be replacing d equal to m square minus 4m plus 3 equal to 0. Now because 3 is a prime number, so the product of the two root is 3 and sum is 4. The only possible factorization is 1 and 3. So m square minus 3m minus m plus 3 equal to 0. So m common m minus 3, 1 common m minus 3 equal to 0. So the factors are m minus 1 and m minus 3. So the value of m comes out to be 1 and 3. Roots are real and distinct. So if the roots are real and distinct, we have assumed e raised to power mx be the solution. So it means that e power x and e power 3x, they are the solution. So the general solution is their linear combination. So what is, we assume it as c1 y1 and c2 y2. So what is y1 here? E power x. And what is y2 here? E power 3x. So what is the Wronskian of y1 and y2? It is y1, y2, y1 dash, y2 dash. E power x, e power 3x, e power x, 3 times e power 3x. So it is 3 times e power 4x minus e power 4x. So answer is 2 times e power 4x. So the correct answer is option C only. Okay. So if we are given the different function, if all the four options having different function, then we can get an idea about the function using Abel formula. So in that case, we can simply use this formula to get an idea about the Wronskian of a function. But if we are given the constant, we are having two options with the same function. In that case, it means that your complementary function is required. You need the value of y1 and y2 only. With the help of this only, you can calculate the Wronskian of the function y1 and y2. Okay. So these are some different kind of problem that could be framed from this topic, method of variation of parameter. Now let us move to the next method, that is method of undetermined coefficient. So in case of method of undetermined coefficient, what it state that again if we are having a differential equation in the operator form, say f of t of y is equal to rx, and if its complementary solution is c1 y1 plus c2 y2 plus so on cn yn, then what about the particular integral? So in this case, we are going to choose the trial solution. We are going to choose the trial solution. So the trial solution is based on what kind of non-homogeneous function we have. So here we are going to choose the trial solution, but it's based on the your non-homogeneous function. What kind of Rx is there? So if Rx is there, like here we are having some specific cases where we can choose a style of function. If your non-homogeneous function is exponential, or your non-homogeneous function is sin ax or cos ax, or your non-homogeneous function is of the form x power m, a polynomial function, or your non-homogeneous function is of the form e power ax into sin bx, or e power ax into cos bx, e power ax into sin bx, or e power ax into cos bx. Now, if this kind of your non-homogeneous function is there, so one important thing you will realize there, that the same kind of function we'll also get in the complementary part, right? So we'll get this kind of function in the complementary function if the roots of the auxiliary equation, the roots of the auxiliary equation are, if the root of the auxiliary equation are a real number, say m equal to a, because we have assumed that e power a mx be the solution. If m equal to a, it means that e power ax is the solution, right? So it means that the same kind of function may be available in the complementary part corresponding to root m equal to a. You will get sine or cosine if your roots are purely imaginary. That means if m equal to 0 plus minus iota a, and this kind of solution you will get if your root of the auxiliary equation are 0, like m equal to 0, m equal to, like if m equal to 0 is one of the root, then your solution is c1 e power 0x. If it is 2 times 0, m equal to 0, 0, then the root is c1 e power 0x plus c2x e power 0x. That means you will get a linear polynomial. Okay. And if it is repeated 3 times, you will get c1 plus c2x plus c3x square and so on. Okay. So you will get a polynomial function and the root of the auxiliary equation is 0. And you will get this kind of function if the root of the auxiliary equations are complex number a plus minus iota b. Okay. Now the question is, what will be your trial solution in such cases? Trial solution. If your non-homogeneous part is exponential, then your trial solution yp is equal to some constant multiple of e power ax. Here this constant is to be, we need to find out the value of this a, that is undetermined coefficient. Why we have choose a e power ax only? Because basically particular integral is a solution of non-homogeneous part of a differential equation, right? That means when we replace your function here, when we solve the left hand side, it will give you the right hand side. Okay, because your left hand side containing the function and its derivative, and only the derivative of exponential function is the exponential function. Okay, so that's the reason we are using our trial solution as a times e power ax. Similarly, if we have a sine function or cosine function or both, then we can use our trial solution as a1 cos ax plus a2 sine ax. Okay, because the derivative of sine or cosine function is both. Because what is the derivative of sine ax? It is cos ax. Second order derivative is minus sine ax. So it means that either we have only sine ax, or we have cosine ax, or we have a both function. So we need to choose our trial solution as a both sine or cosine function, right? Now, the next one is if we have a algebraic function like x power m. X power m means it may be x square x or x square plus x plus 1. Okay, a polynomial kind of function. So in that case, our trial solution will be a polynomial function of same degree. A1 x power m, A2 x power m minus 1, so on am. Why? Because again, your left hand side containing the function and its derivative. Okay, so if your like differential equation is a naught y double dash plus a1 y dash plus a2 y. So y means if we assume y as a x power m. So what is y dash? It is x power m minus 1. What is y double dash? It is x power m minus 2. Okay, y triple dash x power m minus 3. So it means that the maximum power of the function is equal to the y itself. So it means that we started from this maximum power and we need to consider a polynomial. Basically, we need to consider a polynomial of the same degree. That means if your right hand side containing either x square or x square plus x plus 1, we need to choose our trial solution as a quadratic polynomial. Okay. And the last case is if your left hand side is e power ax into sine bx. Again, the same reason we are going to choose our trial solution as e power ax into a1 cos bx plus a2 sin bx. Okay. Now, one more thing. It may be possible that the function which is present in the right hand side, it also appear in the complementary part, because it may be possible that the root of the auxiliary equation is a. So if the same root is repeated in the exponential complementary part as well, so what we need to do, we are going to multiply it with x power k, because the same kind of function may be appear in the complementary part, because it may be possible that we'll get this kind of root as the auxiliary equation. So in that case, we need to multiply it with x power k. And what is k here? K represent the multiplicity of the root, multiplicity of the root in the auxiliary equation. What does it mean? Like if e power m equal to a is a root of the auxiliary equation and our right hand side is e power x, then how many times this root is repeated? If this the root is repeated one time, then we need to consider k equal to 1. If this root is repeated two times, we need to consider k equal to 2. And if it is repeated three times, we consider k equal to 3 and so on. Okay. Similarly, in case we are having complex root like plus minus r tie, if this pair occur once, we need to multiply it with x power 1. If it is repeated two times, we consider x power 2 and so on. And similarly, if in case of polynomial function, if the root of the auxiliary equation is 0, one root is 0, we are going to multiply it with x power 1. Two zero roots are there, we need to multiply it with x power 2 and so on. And in this case, if your right hand side is exponential with sine or cosine, and the root of the auxiliary equation is already there in the complex form with same a and b, Then, corresponding to each pair of this complex root, we need to multiply it with power of x. Okay. Now, to understand that how we are going to choose the trial solution, let us consider some problem. Okay, so suppose we are going to consider this question here. So the question is, if the complementary function of the differential equation y double dash plus 16y is 16 times sine 4x, its complementary function is already given to us, then by a method of undetermined coefficient, what is the choice of the particular integral? So how do we choose the particular integral? It depends upon the nature of the non-homogeneous function. So what is our non-homogeneous function? It is sine ax. You can see here, if our function is sine or cosine, so what will be the trial solution? We need to consider both sine and cosine function. That means we need to consider here a1 sine cos 4x plus a2 sine 4x. But before we are going to fix it as a particular integral, we need to check that either we need to multiply it with x power 1 or something. How do we get an idea? Firstly, we need to check that what are the root of the auxiliary equation. So here it is given that the complementary solution is this one. Complementary solution is cos 4x and sin 4x. And this solution is obtained corresponding to the root of the auxiliary equation as 0 plus minus 4 iota. Okay. And you can see here cos 4x and sin 4x is already our trial solution, and this function already appear in the complementary function. So it means that we are going to multiply it with x power 1. We are going to multiply it with x power 1. So this will be our trial solution in this case. Okay, because the same kind of function already appear in the complementary part. So, and because this function appear corresponding to the complex, like I told you, that if we have a sine or cosine function, and if the root of the auxiliary equation are also 0 plus minus iota a, then we are going to multiply this trial solution with x power k. K means how many times this root appear. So because we have a one pair of sine and cosine function only, it means that it has a one pair of complex root. You can see here, if I write its equation, it is d square plus 16 times yc equal to 0. This is the complementary function, homogeneous differential equation. And if we assume e power mx be its solution, then its auxiliary equation is m square plus 16 equal to 0. So what is the value of m? Square minus 16. So the value of m comes out to be plus minus 4 iota. So if we get this kind of root, then we need to multiply it with x power 1 corresponding to each pair of complex roots. So one pair is there, we are going to multiply it with x power 1. Okay. So how do we calculate the value of a1 and a2? So because yp is a particular integral, because although the question asks in this particular case about the trial solution, so in this case the correct answer is option B. This is our answer. But if we are interested to find out the value of a1 and a2 also, then what we need to do, because yp is a particular integral, so it means that it must satisfy this equation. It must satisfy this equation. So what we need to do, we need to firstly find out its second order derivative. So what is yp dash? First function, derivative of second, second function, derivative of first, derivative of x is 1 times a1 cos 4x plus a2 sin 4x. So if we compile them, then we can get here the coefficient of cos 4x is a1 plus 4a2x and the coefficient of sine 4x is a2 minus 4a1 x. So similarly, if we calculate second order derivative, again we apply the product rule. First function derivative of second cos 4x into derivative of 4a2 x is 4a2 and a1 plus 4a2x into derivative cos 4x is minus 4 times sine 4x plus sine 4x as it is. Derivative is minus 4a1 and a2 minus 4a1x as it is. Derivative sine 4x is 4 cos 4x. So again, if we compile the coefficient of cosine or sine function, so the coefficient of cos 4x is cos 4x coefficient is given by this term and this term. So 4a2 plus 8 4a2, it is 8a2 minus 4a1x minus 16 times 1x 4 into 4, right? And what about the coefficient of sine 4x? The coefficient of sine 4x is one term is this one, another one is this one. So minus 4a1 and minus 4a1 is minus 8a1 and minus 16a2x. Okay, so if we substitute this value, because y is a particular integral, it must satisfy this equation. So I'm going to substitute this value here. So yp double dash is cos 4x into 8a2 minus 16a1x and sine 4x, its coefficient is minus 8a1 minus 16a2x and plus 16 times yp. What is yp? Again, this is your yp. So the coefficient of cos 4x is a1x and the coefficient of sine 4x is a2x. And your right hand side is 16 times sine 4x. So you can see here in the right hand side there is no term containing x times something, and we have chosen the trial solution as x times this function. So it means that after solving the left hand side, your left hand side and right hand side should be comparable. That means there should be no term in the left hand side which containing x into cosine or x into sine function. Okay, so you can see here, if we check, this is minus 16 cos 4x, it cancel out with 16 times a1x, and here also it is 16 times a2x, 16 times a2x, it cancel out. What we left with here is 8a2 cos 4x minus 8a1 sine 4x is equal to 16 times sine 4x. So, but there is no term of cosine term, it means its coefficient is 0. Now comparing the like term cos 4x with cos 4x and sine 4x with sine 4x. So the coefficient of cos 4x is 8a2 equal to 0 and the coefficient of sine 4x is minus 8a1 equal to 16. So the value of a2 comes out to be 0 and the value of a1 comes out to be minus 2. So what should be the solution? Particular integral. So your particular integral yp will be a1 is 0, a1 is minus 2, so minus 2 cos 4x plus 0 times sine 4x times x, that is minus 2x cos 4x. This is the particular integral in this case. Okay. Although I, if the question is based on the particular integral, we need to find out the particular integral. In that case, we can use operator method, which we'll discuss in our next video. But basically, we are going to use to find out the trial solution only using method of undetermined quotient. Okay. So I just want to show you the process how we are going to solve the problem using method of undetermined quotient. But otherwise, our question is over when we have chosen this trial solution only. Okay. So if your right hand side is sine or cosine, then we are going to choose the trial solution as a1 time cos function as well as a2 times sine to x, and we multiply it with x power k depend upon that either the same kind of function appear in the complementary part and how many times it appears. Let us consider another problem. It will give us more clarity, right? Like in this case, you can see here our right hand side is exponential function. So according to this, what will be our trial solution? If your function is exponential, then your trial solution is a time exponential function. It is a time e power minus 2x. But before we are going to proceed, we need to see that what are the root of the auxiliary equation. So consider the homogeneous differential equation yc double dash 4yc dash plus 4 times yc equal to 0. So its operator form is d square plus 4d plus 4 times yc equal to 0, where d stand for d by dx. So we are assuming let yc equal to e raised to power mx be its solution. So in this case, its auxiliary equation will be m square plus 4m plus 4 equal to 0. 4 is already a perfect square 2 square and 2 plus 2 is 4. So it is basically m plus 2 whole square equal to 0. So the value of m is minus 2 and minus 2. And because we have chosen e raised to power mx with the solution, so it means that e power minus 2x is the solution which appear 2 times. So in that case, what will happen? It states that we are going to multiply it with x power k if the root of the auxiliary equation is a. And what is k? K represent the multiplicity of this root in auxiliary equation. So how many times this root appear in the auxiliary equation? Here we have e power minus 2x. So what is a? Minus 2. And this minus 2 appear 2 times in the auxiliary equation. So in this case, what will be the trial solution? So our trial solution is a e power minus 2x into x square. Okay. So what is our trial solution? A times x square e power minus 2x. So this is the trial solution in this case. Okay. Right. Let us consider another problem here. Now in this case, we are given in this case, if we just look at the right hand side, it's containing two exponential functions. So in this case, what will be our trial solution? Both the exponential functions are there. So we have a times e power minus x and b times e power x. But now we need to check that either we need to multiply each of this function with some power of x or not. So firstly, we need to consider homogeneous differential equation. Consider yc double dash 2 times yc dash minus 3 times yc equal to 0. So its operator form is d square minus 2d minus 3 times yc equal to 0, where d stand for d by dx. So we are assuming let yc equal to e raised to the power mx be its solution. So its auxiliary equation will be m square minus 2m minus 3 equal to 0. Again, 3 is the prime number. Only possible factorization is 3 and 1. So it is m square minus 3m plus m minus 3 equal to 0. So here m is common. m minus 3, 1 is common, m minus 3 equal to 0. So the factorization is m plus 1 and m minus 3 equal to 0. So the roots are minus 1 and 3. So what is a here? Here a is minus 1, and what is a here? Here a is 1. So 1 is not repeating, minus 1 is repeating. How many times? One time. So it means that we are going to multiply it with x power 1, but this function retained as it is because a equal to 1 is not a root of the auxiliary equation. So what is the trial solution? Ax e power minus x plus b times e power x. This is the correct answer in this case. Is it clear to all of you? I hope so. Okay, one more problem. I think I forgot to add one question here based on the algebraic function. Let me consider here the problem as, suppose we are given a problem here like y power 4 plus 8y double dash plus, okay, we can consider here y triple dash plus 16y double dash equal to 8x plus 16. So what will be the trial solution in this case? What will be the trial solution in this case? Okay. So on the basis of the right hand side, if you just look at the right hand side, it is the linear polynomial. So when you have a polynomial function, in that case, what we are going to choose? We are going to choose the trial solution as a polynomial function of same degree, power m. So here the power of x is 1. On the basis of this, our trial solution should be yp equal to ax plus b. It is a linear function. Now, before we are going to proceed, we need to check that either, because we will get polynomial function corresponding to the root m equal to 0. We want to see that either the same kind of root appear in this equation as well. So we write its, first we need to find out its root of the auxiliary equation. So homogeneous differential equation is, its operator form is d power 4 8 d cubed 16 d squared times yc equal to 0, where d stand for d by dx, and we are assuming let yc equal to e raised to power mx be the solution. So its auxiliary equation will be m power 4 8 m cube 16 m square equal to 0. You can see here m square is common, m square plus 8m plus 16. So 16 is 4 square, 4 into 2 is 8. It is m plus 4 whole square, 0. So it means that m square equal to 0 means m equal to 0, 0. And here m equal to minus 4 and minus 4. So the solution is c1 plus c2x corresponding to this repeated root. And this is c3 plus c4x e power minus 4x corresponding to this repeated root. Now you can see here m equal to 0 root repeated 2 times. And we know that we get a polynomial function corresponding to root m equal to 0. And if this root is repeated k time, then we need to multiply this whole trial solution with x power k. So what will be the trial solution in this case? We need to multiply it with x power 2, because 0 is repeated 2 times in this case. So what will be our trial solution? Ax cube plus bxk. Like I told you, when you substitute this value in the left hand side, it must satisfy right hand side. So if you calculate its first order derivative, It is 3ax square plus 2bx. Its second order derivative is 6ax plus 2b. You calculate its third order derivative is 6a. If you calculate its fourth order derivative, it is 0. And because yp is a particular integral, so it means that 16yp double dash equal to 8x plus 16. So fourth order derivative is 0, third order derivative is 6a, second order derivative is 6ax plus 2b equal to 8x plus 16. So this is 96ax and this is 48a plus 32b equal to 8x plus 16. So you can see here, the left hand side is a linear polynomial, right hand side is also linear polynomial. So by comparing the like term, you can get the value of a and b. So 96a equal to 8 and 48a plus 32b equal to 16. So a is 1 by 12, so 48 by 12 plus 32b equal to 16. So 32b equal to 16 minus 4, that is 12. The value of b is 12 by 32, 3 by 8. So what is the trial solution, or what is the particular integral? It comes out to 1 by 12x plus 3 by 8x square. This is the particular integral in this case. Okay, so our main motive is that what should be the trial solution. Okay, so the trial solution will be on the basis of the non-homogeneous part. We can choose our trial solution as ax plus b. We need to multiply it with x power k. It depends that how many times the root repeated in the auxiliary equation, and we get a polynomial function corresponding to the root m equal to 0. Okay, similarly, if we have an exponential with sine or cosine, then in that case our trial solution is this function, and we are going to multiply it with x power k. Depends that either this complex pair repeated once or twice in the auxiliary equation. Accordingly, we are going to multiply it with x power 1 or x power 2. Okay, I think that is enough for this topic part. You just practice the problem of this part. If you still face any doubt or any problem related to this topic, you can post your queries. I'll try to find out the solution of the same, and I'll try to provide you as well. Okay, thank you and have a nice day.